Start. In this video, we're going to look at a property that what makes an integer divisible by 9. And like in the last lecture, we're going to use this notation that a number is divisible by 9. Let's say n is divisible by 9. We're using this notation. 9 is a divisor of n. So 9, this straight line, and n means that 9 is divisible by n is divisible by 9, and 9 is a divisor of n. We know this property. A lot of you already know this property, that a number n is divisible by 9 if and only if the sum of the digits of n is divisible by divisible by 9. If and only if the sum of the digits of n is divisible by 9. Let's first look at one example. Okay, let's check if 9 is a divisor of 1, 2, 3, 4, 5, 6, 7, 8, 9. This number of a 9-digit number. If this number is divisible by 9. Now, if you do division and check the remainder, of course you can do it, but it's not going to be a lot of fun. Instead, we can using this property to check. Because of sum of digits is just equals 1 plus 2 plus 3 plus 4 plus all the way to 9. And this, we know the formula of half of 9 times 10. Right? By just pairing them together, and which you have a 5 in the middle. And this is going to be equal 45. Now, 45 is a multiple of 9. So we know that 9 divides 45. So we know that the original number is also divisible by 9. In here, we're going to check. We're going to prove this property. We're not going to prove the general case. Instead, we're going to prove by a special case. And we're only going to prove that an integer, a 4-digit number integer, that's called n, is a 4-digit number. It's A, B, C, D. So the 1,000 digits has a digit A, the 100 digits is B, and the 10 digit is C, and the unit digit is D. We're going to show that 9 is a divisor of n, or n is divisible by 9, if and only if 9 is a divisor of A plus B plus C plus D for this n. The proof is going to be pretty general. If you understand this proof, you can try to write down for any n, say n has many, many digits, the proof is almost identical. All right, let's see. So n equals A, B, C, D. That means if we know this, the meaning of a 4-digit number, it really means that A is 1,000 digits. So it's A, this number is A times 1,000 plus B times 100 plus C times 10 plus D. A 4-digit number, that's the meaning of the 4-digit number, decimal numbers. Now, this number, if we write down this 1,000 as 999 plus 1 times A plus 99 plus 1 times B plus 9 plus 1 times C plus D. So for this n to be a multiple of 9, we know that 999 is a multiple of 9, so 999 times A is a multiple of 9. plus 99 times b is a multiple 9. Let's just write down this, like using distributable law first. Plus c plus d. Okay, for this n to be a multiple 9, or 9 is a divisor of n, it really means that because this is a multiple 9, so we can just forget about this, and forget about this, forget about this. So 9 is a divisor of n is equivalent to 9 is a divisor of a plus b plus c plus d. Because all this 999 times a, 99 times b, 90 times c, they are a multiple 9 already. So we can just throw them away. Left with 9 is a divisor of n if and only if 9, sorry, it should be 9 is a divisor of a plus b plus c plus d. So now you have this simple rule that n is divisible by 9 if and only if the sum of the digits of n is divisible by 9. And here we proved that for n is a 4-digit number, this is true. And clearly this proof for 3-digit number is going to be true, 2-digit number is going to be true, and by the same reasoning for any numbers with many digits, it's also going to be true. And this property is very useful because now instead of checking a very large number, if that number is divisible by 9, you can just do the summation of all its digits and check if it's multiple 9. And for some reason that if the summation of this number is huge, we can recursively using this. If the summation is a still huge number, you can say, okay, instead of checking that number is divisible by 9, we again check the sum of its digits if that number is divisible by 9. We can keep doing it. And this is a very useful property. Now, this property can be using the same argument. It can be also shown that n is divisible by 3 if and only if the sum of the digits of n is divisible by 3 as well. And that's the end of this lecture.